This is a problem from section 7-3, similar to your homework. Listed below are measured amounts of lead in micrograms per cubic meter in the air. The EPA has established an air quality standard for lead of 1.5 micrograms per cubic meter. The measurements shown below were recorded at a building on different days. Use the given values to construct a 95% confidence interval estimate of the mean amount of lead in the air. So here's our data set, and so we're asked to construct a 95% confidence interval. So we have to go through a couple of pieces of information. First, we have to note that sigma is not given. So n is less than 30 clearly, so let's just assume that this is normally distributed. So we're not assuming that the sample is normally distributed because it doesn't look like it is, but we can assume that the whole population is normally distributed. Because of these two pieces of information, mainly because of the first one, that sigma is unknown, we're going to use the t distribution. And we're going to use a t interval from our calculator. So let's go ahead and look that up in our calculator. We have the data. Since we have the data, we're going to punch that into our list. So let's go to list 1 by going to stat and edit, and then we'll select list 1. I see that there's something in there already, so I'm going to go up to L1 by using the up arrow, and I'm going to clear this. So I'm going to hit clear and then enter, and so that clears out the whole list. And now I'm going to type in the values. So here are my 6 values, 1, 2, 3, 4, 5, 6, and then from here I'm going to go to stat and tests, and then I'm going to scroll down to t interval. So we're using the t distribution here, and our t interval is down a little bit below the z interval here, the t interval, number 8. So I'm on number 8, so I'm going to press enter. And then you have a choice for your input. Do you have the data or do you have statistics? We have the data. Let's take in our data. Our next option is list. We are actually in list 1, so if it's not there, let's go ahead and press second function and the number 1. That gives us L1 in our list. Our frequency is going to be 1, and the next option is our C level. That's our confidence level. It's 0.95. So 0.95 is already there, but I'm going to retype it in anyways, and then we'll ask it to calculate. Our t interval gives us this result using parentheses, and so what we're going to do is write it slightly differently. First, let's write it using the left endpoint, and then instead of using the parentheses notation, I'm going to use the less than sign. And then we're measuring the mean, so the population mean is mu, and then another less than sign, and then the upper bound. So this is our confidence level. We can write this confidence level in words. So we'll start off by saying that we are 95% confident. That's using the confidence level. And then we'll mention that the true mean is between. We have a negative here. I can't imagine measuring something with a negative micrograms per cubic meter of lead, so we'll do it with 0, and then we'll say 3.557, and we'll use the microgram notation, micrograms per meters cubed. So here is how we would say this result in words. This particular problem has another part to it, and it's asking us, is there anything about this data that suggests that the confidence interval might not be very good? So we went negative on this confidence interval, but I don't think that's what they're referring to. If we look at the original set of data, we see that 4 out of the 6 numbers are less than 1. There's one that's a little bit bigger than 1, and then this first measurement is 5.4. So that seems like it's quite a bit. So we seem to have an outlier that might skew this particular set of data a little bit too much to the higher end. So it seems like we have an outlier in the 5.40 micrograms per meters cubed as a measurement. Now in the actual homework set, here are the choices that they gave us. If we look at the choices, we see yes, the confidence interval does not contain 1.5. It actually does contain 1.5. If we look at that number, it's between 0 and 3.557. So this can't be a good option. Yes, because the sample mean is greater than this. Well, the sample mean, if we look at our calculator, is 1.56. It's a little bit greater, but I don't think it's enough to point at it as the mean. So the next one, no, the data appears to be normally distributed. We can assume that, but we're looking to see if there's something that's not very good about this. And then the last one says yes, the value 5.4 appears to be an outlier. So that's what we had observed for this particular data set. So it looks like that's it. We have 5.4 as an outlier. Okay, I think that's it for this problem. Good luck.